Hi everyone! Welcome back to integralcalc.com. Today we're going to be doing another example of velocity and acceleration vectors. And like the last problem, we're also going to find speed. So the problem we're given is r of t equals ti plus 3e to the t times j plus 4e to the t times k. And whenever we're dealing with velocity and acceleration vectors, we need to remember that velocity is going to be equal to the first derivative of our function, and acceleration is going to be equal to the second derivative. So the first thing that we're going to do to try to find velocity is take the first derivative of r of t. So it's going to be r prime of t, and that's the same thing as velocity. So when we do that, and we're taking the derivative of a function here that includes I, j, and k, we're going to ignore I, j, and k like they're not even there at all, and then treat t obviously as our variable. So if you pretend here that this first term, instead of being ti, is just t, we take the derivative of t, and of course we get 1, right? Because it's just like taking the derivative of x. When we take the derivative, it's 1. So the derivative is going to be 1, and then we add the I back in, and we just have 1i, which simplifies here to I. So same thing here with this 3e to the t times j term. Ignore the j, pretend like it's not even there. We've got 3e to the t. Taking the derivative of that, we'll get 3e to the t. It stays, because remember, the derivative of e to the x is simply e to the x. It's the same thing. So that whole term is going to stay, and then we just add the j back on. So we end up with 3e to the t times j, the same thing that we started with. And we're going to do the same thing for this coefficient here on k. It stays the same at 4e to the t times k. So then that means that we can now take the coefficients in front of I, j, and k and use them as the direction numbers for our velocity vector. So we pull the coefficient off of I, which is simply 1, the coefficient off of j, which is 3e to the t, and the coefficient off of k, which is 4e to the t, and we put those three together in that same order, I, j, and k, to get the direction numbers here, and this is our velocity vector. It's as simple as that. So acceleration vector, remember we said it's the second derivative, so we're going to take the derivative of our first derivative here, and of course we'll get 0 for this term here with I, because remember we're ignoring I, j, and k and only looking at the coefficients, and in this case the coefficient on I is simply 1, and the derivative of 1 is 0, as is the derivative of any constant. So that's going to be 0, and that whole I term is going to go away. The derivative, again, of 3e to the t is 3e to the t, same thing, we put the j back on, and this 4e to the t times k stays the same as well. And now to find the acceleration vector, we take the coefficients, and remember, we no longer have an I term, which means the coefficient on that term must be 0. So we have 0 there, and then the coefficients on j and k, 3e to the t and 4e to the t. So there's our acceleration vector. And then to find speed, all we do, we can ignore the acceleration part completely. We go back up to the velocity vector here, and we take these three direction numbers, 1, 3e to the t, and 4e to the t, and we square each of them. You see we have 1 squared, 3e to the t squared, and 4e to the t squared. And we add them all together, and then we take the square root. So that's how we set up our equation for speed, and then it's just a matter of simplifying, and we basically just square everything out. So obviously 1 squared is 1, 3e to the t is 9e to the 2t, and then 4e to the t squared is 16e to the 2t. And that's really all we can do. Oh, sorry, just kidding. Of course, we can combine these second two terms, because we have e to the 2t and e to the 2t. We have something with the same base and exponent there. So we can combine them, and we just simply add them together, obviously, and we get 25e to the 2t. So, but from that point, that's really all we can do to simplify. So this is the equation that represents the speed. So when we put all three of those things together, here's our velocity vector, our acceleration vector, and our speed. That's the final answer to our problem, and just keep in mind that Now that you've set all three of these up, if you were asked to find velocity, acceleration, and speed at a given point in time, you would plug that value in for t to each of these, and that would give you velocity, acceleration, and speed at any given point in time. So I hope that example helped you guys, and I'll see you in the next video. Bye!